Hello developers. In this video, I will show you how to integrate Google Play's in-app update feature in your Android app. I have already done a video on this topic, but that procedure was outdated currently as Google has updated the APIs for in-app update handling, and also there are changes in the in-app update testing requirements. So in this video, I am going to explain the implementation of in-app updates as per the latest Google Play's documentation. And also I will show you how to test both immediate and flexible updates from the emulator. And at the end of this video, I will give you some tips to troubleshoot when in-app updates are not working at your end as expected during testing. So don't skip the video and watch till the end. Hello friends, welcome back to Ireka Tech Solutions. First, let's see the implementation part. In-app updates implementation is very simple if you follow this Android documentation page. I will give this page link in the description box for your reference. Now, open the Android Studio. First decide where do you want to show the in-app update alert to users. Because you may not want to give the update alert to the user for every new update. So decide when and where do you want to show the in-app update to user. For example, I want to show the in-app update alert on the app's home screen. Then go to that particular activity to start implementing the in-app update feature. Okay, now the first step is set up your development environment. You need to include this play app update dependency in your build.gradle file. So copy this, open modules build.gradle file, add that library under dependencies. Now sync the Gradle files. Okay, sync is successful, no errors. Okay, if you are coding in Kotlin, then you will have to include this Kotlin in-app update library also in your build.gradle file. Next step is check for update availability. Here we will create the app update manager instance from app update manager factory. And from app update manager, we will get the app update info. Then after getting the app update info, we will check if there is an update available and whether we can apply for immediate update. There are two types of app updates, immediate and flexible. Immediate update alerts are full screen alerts that require the user to update and restart the app in order to continue using it. This is best for cases where an update is having security patches or any other core functionality changes. And flexible updates provide background download and the user can use the app while downloading the update. For example, you might want to encourage users to try a new feature that's not critical to the core functionality of your app. So in this video, I will show both the updates, but first let me show you the implementation of immediate update. So copy this whole code. In the project, create a method called check for in-app update and paste the code inside. Okay, clear the errors by importing the required classes. Okay, pass the context to the create method. We will have to request the immediate update now. Go to documentation, come down to start an update. Copy this method called start update flow for result and paste it here. Okay, we have to pass the activity result launcher instance. So here go to the section get a callback for update status and copy this register for activity result callback method. And inside this check for in-app update method only, paste the code at the end. Assign this to activity result launcher and create a class variable of activity result launcher. Okay, now clear the import errors. Log message. If you want, you can use the log message or else just comment this log line. So we have created a method to check in-app updates. Here on in-app update info success, if the update available, we are requesting for the immediate update alert. Now call this check for in-app update method inside onCreate method. Okay, the coding part is done. Now test the app. Run the app. I don't think so it will show the update alert. Let's wait. Okay, as expected, alert is not showing because the in-app update testing requirements have changed by Google. Make sure that the app that you are using to test in-app updates has the same application ID and signing key as the version available from Google Play. Means, first of all, to test the in-app updates in your app, you should already be having a production version uploaded to Google Playstore. And the application ID in your app build.gradle should be same as the application ID for the app available in the Google Play Store. And the signing key also should match. Means you cannot run the app directly from your Android Studio. You will have to use the signed build to test the in-app updates. So to test in-app updates, we can use internal app sharing feature from Google Play Console. Because the internal app sharing is the easiest way to upload, share and download the app build files. And unlike closed and internal test tracks, the internal app sharing builds doesn't wait for Google's review and they are immediately available to testers for download. And also you can reuse version codes in the internal app sharing builds. To know more about internal app sharing, you can watch my video. I will give this video link in the description box. So to use the internal app sharing, go to your Google Play Console account, select your app. In the left hand menu options under Release Setup, select Internal App Sharing option. Now click on this link. It will open the internal app sharing page. Here we need to upload the signed builds. So come back to the Android Studio. Change the version code if you want. Then sync the Gradle files. Now generate signed app bundle. Okay, signed bundle is ready for the version code 7. Now upload this AAB file to internal app sharing. Give the version name. You can give any name to identify your release build. I am keeping it 1.7 only. So this is our testing build with immediate app update implementation. But to test this build, you should upload a version of your app that uses a version code that is higher than this version code. So change the version code to 8 and changing the version name also. Sync the Gradle files. Generate the signed build with version code 8. Okay, signed build generated. Now go to internal app sharing. Upload the version 8 build. Upload. So we have both the version builds uploaded. Now we can start testing. But to download those builds in your emulator, make sure you have the Play Store app installed on your emulator. If not, install the Play Store app by watching this video. Now open the app and sign into Play Store using your any Google account. If you are testing on the real device, you can skip this step because Play Store would have already been configured on your device. Okay, so we have signed into Play Store. Now we need to enable internal app sharing in the Play Store. Click on this icon, go to Settings, click on About, tap on the Play Store version 7 times continuously. It shows you are now a developer. Now go to General, Developer Options, Enable Internal App Sharing. Turn on. Okay, internal app sharing was enabled in the Play Store. So the Play Store is configured completely. Now let's download the builds for testing. We will install this version 7 build in the emulator so that it will show the update alert for version 8. So copy this link, open the browser, paste the link. An internal test version of this app has been shared with you. Open in Play Store app. This app is an internal test version. Now click on install. So it is installing the version 7 build. Done. Open the app. Okay, alert is not showing because Play Store doesn't know there is an update. So copy this version 8 link. Open it from the browser. Yes, it shows update option to update the existing version 7 build on emulator. But don't click on update here because we have to test the app update alert on the app. Now open the app. Yes, it shows immediate app update alert. To use this app, download the latest version. See, it is a full screen alert with update. Means you can't use the app until you update your app to the latest version. Here you are given a close button also to cancel the update. But again, if you open the app, you will be displayed with this update alert again. If you click on update, it will start downloading the new version. And after download, it starts installing automatically. Once the new version got updated, then it will relaunch the app directly. So this is immediate in-app update implementation. Now let's change the code for flexible update handling. Go to documentation page. Come down to handle a flexible update. But first change this update type to flexible in the code. Now before starting an update, register a listener for updates. So copy this line, add it before starting an update, that is before on success listener. Now let's initialize the listener. So come down, copy this code, add after the check for in-app update method. Okay, import the classes. Now go back and copy this pop-up snack bar for complete update method also. This is to notify the user about update installation and request user confirmation to restart the app. Okay, here app update manager instance showing error. So we need to make this as class variable. Okay, error is gone. Here you can pass a custom layout to show the restart notification or use the container ID. And this color also you can give any color from your app's color theme or else simply use Android colors. I am using hollow blue dark to show this restart option. So we have registered the listener in check for in-app update method and we will have to unregister it when no longer needed. So override onStop method and use this unregistered listener code inside this method. Next, we need to override onResume method to check for any pending updates. Means the update was downloaded but not installed. Then on resume, the user gets notified with restart pop-up. So copy this on resume method also and paste it in the code. Yes. So for flexible update, we will implement the listener to check the download status in the background after download. We will show the user a pop-up snack bar to restart the app and we will unregister the listener when not required anymore. So the flexible update implementation is done. Now testing. So we need to create a signed build again. The last updated version was 8, but as we can reuse version codes for internal app sharing, I will create a new signed build with version code 7 only, so that I can get the update request for version 8. So changing the version code to 7, sync the Gradle files, generate signed build. Okay, now upload this version 7 build to internal app sharing. Giving the version name as 1.7.1 to differentiate 1.7 with immediate update and 1.7.1 with flexible update. Okay, done. Now delete the app from the emulator because this is the version 8 build updated through immediate update. Now copy this 1.7.1 build link and open in the browser. Oh, it is showing the public version build, not the internal app sharing build. There was a glitch. In such case, try to clear the cache for Google Playstore app. Okay, now open the link once again from browser. Yes, it is showing the internal app sharing build. Install it. Okay, now open this version 8 build in the Play Store app to inform the Play Store that there is an update. But don't update the app from here. Go back to the downloaded app, open it. Yes, the flexible update alert is displayed. To use this app, download the latest version. You can keep using this app while downloading the update. Okay, click on update. The downloading started at the background. You can see the download status in the notification bar. So once the download completes, you get a pop-up snack bar with restart button. But if you don't click on restart, then on next launch, you will get the pop-up again to remind you to update your app. So if you click on restart, it will install the update and relaunch the app automatically. So now this is my version 8 build updated through flexible update. Hope you understood how to implement and test both immediate and flexible updates in your app. Here you can ask, how would I know whether to check for flexible update or immediate update? For that, there are two signals to identify the allowed update type. One is update staleness, another one is update priority. This update priority concept is good. Based on the priority level, you can decide whether to request for immediate update or flexible update. But the implementation is not user friendly. You need to edit the release track in the Google Play Cloud API on every new update. And some reported the priority value is not written properly from the client API. So if Google can make the changes to include the priority level inside the Gradle files itself while making the release build, then it would be more useful for the developers. And mainly, even you change the release tracks on Cloud API, you cannot test this feature. The in-app update priority field is not supported when uploading your app to internal app sharing. So we can ignore this for now. The next signal is update staleness days. This can help you decide whether you should initiate a flexible update or an immediate update. For example, you might wait a few days before notifying the user with a flexible update and a few days after that before requiring an immediate update. Means based on the number of days since the update become available, we can decide the update priority level. Let me show you how to handle this. Create an integer variable to the days wait for the flexible update. For example, 20 days. And for immediate update, we can wait for 40 or 45 days. It depends on your app type. You can decide when you can ask user to update the app. Okay, let's copy this start update flow method into another method. And pass the update type and app update info parameters. Now call that method here by passing those values. Okay, now after the update available, check for client version staleness days. If the update version is available for more than 45 days, then request for immediate update. Else if more than 20 days are over from the update available in the Play Store, then you can request for flexible update. So this is the code. Based on the staleness days, you can decide the priority of the app update. But unfortunately, this also we cannot test because staleness days always returning null while testing the app from the internal app sharing. But this should work in the real scenario when you update the production version. Hope you got it. Okay, now let me give you some tips to troubleshoot the app if you don't get the in-app update alert in your Android app. First point, in-app updates are only available for the published apps. Make sure you have that app published to Play Store at least once. Second point, make sure you are using the signed build to test in-app updates. You don't get the update alert while running the app from the Android Studio directly. Third point, Google Play can only update an app to a higher version code. So make sure that the app that you are testing has a lower version code than the update version code. The next point, to test in-app updates from internal app sharing, make sure you enable the internal app sharing in your emulator or device Google Play app. Fifth point, even after verifying the above points, if you are still not getting the update, then clear the cache for the Play Store app from device settings and try loading the new version again. Finally, check or debug your code for any errors and exceptions. Okay, hope you got the clear idea on in-app updates, implementation and testing. If you like my explanation, please like the video, comment and subscribe to iRekha Tech Solutions. Thank you.